This is a read. And that's notes. So take one of each. Yeah. It might have been in here at the time, the original version. Yeah, let's see, there's about 3-4 minutes left on the quiz. If you finish early, just keep it in front of you. We're gonna just grade it in class. You have 1 minute left. Make sure you have an answer down for everything. Yeah, it's time. So let's see. We're gonna go over it and go over the quiz in class here. Everybody's going to just grade your own quiz. So it'll be on the honor system that you're not changing answers as I tell you what the answers are. As a reminder, if you do that, then that would be an academic integrity violation. I will report you to the Academic Integrity Board, and my personal belief about academic integrity issues is that I want to be able to trust you all in class in order to be able to do things like grading assignments in class. I think that's important to get the immediate feedback on how you did on an assessment. And then also to be able to, when we're doing the labs and homeworks, to have you able to collaborate very openly with each other. I think that's important. So because of that, I do take, if there is a violation of what is already a very loose policy, I take that seriously and definitely will report, no exceptions. Yeah.
What if I scribble it beforehand?
Yeah, so it's okay if you like scribble things out beforehand. Basically, it's, I believe you are all adults, and I'm going to take your word at whatever you say it is. So just please don't make me regret that. Okay. So, and again, the reason we're going over them in class is to get that immediate feedback on how you did. And that's both, I remember as a student, I always liked that. I hated waiting for a while just to know, like, okay, I thought I did good, but did I actually do well or not? But also, a lot of research studies in education show that that actually helps people learn. That the point of these assessments, these quizzes, one of the points is to help me like understand where everybody is at in the class, but really the more important point is to help you all actually continue to learn. And so all of these quizzes that we'll be doing throughout the semester, they're not just designed to let me know how all of you are doing, but they're designed to help you actually cement this material in your head. So the first problem is asking LI, just LI by itself, how many list items are there? There's 4 of these down here, so the first one is 4. And I'll write all the answers up here in green as I say what they are. Then the second one, dot bold. So this one, there's a lot of bold classes spread throughout here. So it could have been easy to miss one, but there's 4 down here, the LIs in this image. So there's 4 here. Then there's 2 P's up here. So it's 4 plus 2 is 6. Plus there's 1 more up here. So there's 7 total. So number 2 is 7. Number 3, li.bold. So this is all of the LIs that also have the bold class, and there's 3 of them down here. And then number 4, li space dot bold. So these 3 no longer apply, but this one inside of the li does. So the answer is 1. Number 5, h2 plus p. So H2, there are 2 H2 tags, this one up here, this one down here. The plus is the immediately adjacent sibling. Though up here we have 1 immediately adjacent sibling, this P. Down here there is no P next to the H2. We don't count the thing above, we only count things below. So only this P class right here, so the answer is 1 for number 5. Number 6, div greater than dot bold. So we have a div right here and a div right here. And we're looking for the greater than means that it must be an immediate sibling, not just a descendant, but an immediate sibling. So let's start with this div up here. And we have a descendant that is class.bold inside of here, but it's not, it's a grandchild, it's not a child. So the greater than sign means we don't count this one. So that doesn't count. Down here we have this div. And then there's these 2 bolds right here, both children of this div. We have some more bolds down here, but again, they're descendants, not children, so they don't count. So it's just these 2 right here, so 2 for number 6. Number 7, hashtag body img. So here is our hashtag body tag, this div right here on line 10, and then space img. The difference between the space and the greater than, again, is that the space, it can be grandchildren, great-grandchildren, and so on. So this image tag counts as being under this div right here. There's another image tag right here. It is under a div, but it's not under a hashtag body. So this one does not count, only this one down here. So we have a 1 for number 7. Sorry, thank you. Number 6, the answer is 2. Number 8, h1 space div. So we have an h1 up here at the top, and we're looking for divs inside of the h1. There are no divs inside of the h1, so the answer is 0 for 8. Number 9, h2 plus li. We have an h2 down here and an h2 up here. There's no li's inside of this one, so we can skip this one and look at this one down here. The plus, again, is the immediate sibling, adjacent sibling. The adjacent sibling is an OL and not an LI, so it's a 0 for number 9. And then number 10, we have image, then the tilde, so looking for siblings of image, and there are no siblings of this image. It is an only child. These ones might look like siblings, but they're, like I said, would be aunts, uncles of image. So they don't count. And so we get a 0 for number 10 as well. Total up your, the number that you got correct, put that at the top where it says /10, and then pass all the quizzes up here. I don't need any of the, I don't need your other sheets, just the one where you have the answers on them. Are there any other quizzes? Okay, let's calm back down here for a second. One last note about the collaboration policy, academic integrity policy related to this quiz is that you're also not allowed to discuss the quiz with the later section. And so that includes even saying things like, oh, I thought the quiz was easy today, or I thought the quiz was hard today. So please just don't talk about it at all with them until after they've taken it. Okay, today we're going to start talking about the Python programming language. And we have a new textbook that we're using, this Automate the Boring Stuff. It's a really famous textbook in Python. And again, it's all freely available online. And this week, we're going to be covering chapters 0 up to 3 of this textbook. If you, well, let's see. So first, let's talk a little bit about the difference between Python and HTML CSS, what we've seen already, and what to expect. So one of the key vocabulary words, but again, I'm not going to quiz you on these vocabulary words. You'll just see them a lot, and so it's good to have a working knowledge of them. But this idea of a markup language versus a procedural language. HTML and CSS are what we call markup languages because they describe what you want done, but not how you want to do it. So you specify, here's a paragraph, then a paragraph following it, then a list, just what you want on the web page, and then Firefox figures out the how to do all of this for you. Python is different. It's what we call a procedural language, and here it's called procedural because we're going to specify the exact procedure for doing something. So we're going to actually be specifying the how now, not just what we want done, but how we want it done. And that makes Python a lot more powerful than HTML and CSS. There's a lot of things that we can do in Python that we cannot do in HTML and CSS. And for this reason, a lot of people don't even call HTML and CSS real programming languages. You'll hear people say that a lot. Oh, HTML, that's not a real language, but Python, this would be considered a real language because you're specifying the actual how to do something. So again, because Python is much more powerful, most people will find Python much harder than it was doing things in HTML and CSS. And in particular, if you're one of the people who doesn't have much prior programming experience, again, that's totally okay for this class, but you should expect that this week and next week, as we do the basics of Python, that these will be particularly challenging weeks. So make sure to be putting in enough time studying and going to the student tutor office hours. So while we're talking about the student tutors, over the weekend, the 3 tutors for the course outside of the QCL posted hours on GitHub. Their hours are all on Monday and Tuesday so that you can go to them to get that 48-hour extension and work on the assignments related to this week or future weeks and not get the late penalty. So please take advantage of them. They're all really great at explaining things. So for next class, I want you to visit this link right here and download Python yourself onto your own computer that you're using. This class right here is not a class where you should try to follow along. So I'm going to open up Python here in a second. You shouldn't try to follow along with everything that I'm doing. You can start doing that next class. This class, you should really just try to get like the sense of things about Python and how things are different than HTML and CSS, and the big picture workflow that I go through. Let's see, we'll be visiting this Python tutor site here in a little bit, and then this Python cheat sheet is the other sheet that was up front that you collected with the quiz. So if you don't have a copy, it looks like this. If you don't have a copy of this, then they're up front right here. Maybe since we're talking about this right now, so we're talking about a new programming language right now, so Python. And anytime I think about programming languages, I think about the analogy to like human languages that you've all previously studied, like foreign languages. And part of that is you have to learn like the grammar of the foreign language. This cheat sheet describes all of the grammar of Python. And throughout the semester, we're going to be going through every one of these boxes, talking about what these different grammar sort of things mean. And it looks kind of complicated. There's a lot here right now. But if you think about like, so I was in high school and I studied Spanish. Like Spanish has a lot more grammar rules than can fit on just one page. Any human language has a lot more grammar rules that can fit on one page. And so this may seem a little bit overwhelming at first, especially if, especially if you're haven't done any procedural programming before. But it's going to be significantly less work than learning an actual human language. And you know that here's everything that we need to know right here. And we're going to learn it all. And once you're done, you know Python. There's no like hidden exceptions to anything or irregular things like there are in human languages. Let's see, before we get started for today, one note about Wednesday is that there's a handful of pre-lecture videos that I have here. I think there's 9 of them. And these videos are made by the author of our textbook. They're made to accompany the textbook. These videos are optional, so you're not required to look at them. But again, if you don't have much programming background, I strongly recommend you watch these before class because they will make class on Wednesday much easier for you. Each video is only about 5 minutes long, so it's less time commitment than actually attending a class to watch through all those videos. Any questions about anything so far, Python related or things to do for Wednesday? Okay, then we'll get started talking about Python. I'm going to switch over to VS Code, and under week 2, create another file. I'll call it notes_Monday section1.py. So in HTML, we ended our files with .html. For Python, we ended in .py. py is the extension for Python. And yeah, things in VS Code will work very similar to how they worked in with HTML, but there's a slight difference in that now there's going to be a little green rectangle button in the top right that appears. And this is how we're going to test our code in Python instead of looking at things in Firefox. So always the most simple thing that we start with when we learn a new programming language is a hello world program. So print hello world. The print command will just print whatever is inside of parentheses over here. And then I'll press Control S to save, come up here, hit this triangle button, and you can see down here, let's see. There we go. And it should run for you. For everybody's computer, whether you're on a Mac or Windows, it'll getting this triangle button to actually run your code. It might take some subtle playing around with it. So that's why we want to make sure that you've attempted that by Wednesday, so that on Friday on lab, if you need help getting that to happen, I'll be able to help you out on Friday. Right?
I'm getting a question on VS Code that says, do you want to install the recommended extensions for Python?
So yeah, when you go through the process of installing Python, there's going to be a lot of options that you can check. In general, you can't, there's no wrong answer to any of these questions, but probably you want to do whatever the recommended thing is for everything. Unless you have a good reason why you don't want to do that, do the recommended thing for everything. So with Python here, at the beginning, when we're first working in, say, these first week or two with Python, all of the output that we're going to be seeing is going to happen in this screen down here, which we call the terminal. So up here on the top is our file, down here is the terminal. And so the output's not going to be quite as exciting as it was for HTML, because it's all going to be this sort of text stuff. Let's go ahead and add another, say, goodbye, world. Press the triangle button, and every time I run a new program, it's just going to add to the output down here. After we get sort of the basics of Python down, it'll take us about 2 weeks to do that. Then we'll start combining Python with the HTML and CSS stuff that we talked about earlier, and that's when things will visually start getting a little bit more appealing, and you'll be able to look at code inside of Firefox and things like that. But at the beginning, we're going to be staying just in this terminal down here. So with Python, one of the things about Python, again, procedural, so we're really specifying a procedure up here, that each one of these line numbers is like a step number of first do this step, then do this step. And no matter what I put up here, so print step 3, it's always going to go top to bottom, evaluating one line at a time. Hello world, goodbye world, and then step 3. Python, doesn't matter, vertical white space is always okay to add vertical white space. It has no different meaning at all. But horizontal white space in Python is sometimes important. So if I do this, put some spaces right here, press save, and run it again. Every time I press the triangle button, the verb for that is called either running the program or executing the program or evaluating the program. I'll use all those words interchangeably. So I'll run this program. And now down here, you can see that it's showing an error message. With HTML and CSS, we never had error messages at all. That if we had somehow made a mistake with our HTML, then Firefox did its best to figure out, what were you trying to do, and I'll try to do that. Python is totally different. That if you have the slightest mistake anywhere in your code, then the code just will refuse to run at all. And so VS Code is nice that it'll put those squiggly lines below things where you have these error messages. This is a particular error called a syntax error, which is what's causing the code not to run. And at first, these explanations of these errors will be a little bit confusing, like unexpected indent. What does that really mean? But you'll get the hang of it. And unexpected indent means that it shouldn't have been indented. It should have been all the way to the left. So one of the things that sometimes happens to students, especially new programmers, is you somehow get scared of these error messages. One of the goals of this class is to help you sort of overcome that fear of error messages. Error messages, in my opinion, are actually good things, that they prevented the code from doing something that I didn't want them to do. And it's never bad to just say, I have no idea what this code is going to do. I have no idea if it's correct or not, and just run it and try it and see how things work. But again, computer scientists run experiments, so always be running an experiment to see what your code actually does. So this here, these print statements are sort of the most basic way to take information that you have and get it to the outside world. Inside of these parentheses right here, these are, we call them strings. And strings in Python can be done with single quotes or double quotes. There's no difference in meaning at all between single quotes and double quotes. I personally like to use single quotes for everything, again, because I'm lazy and I don't want to press the shift key if I don't have to. But other people like double quotes, and so you'll see people using both. It doesn't matter at all in this class which one you use. Let's see. The next thing that we'll talk about are variables in Python. And variables are really where the power of Python comes, because this is something that Python has that HTML and CSS don't have. So in a variable, what a variable statement looks like is we have the name of a variable and then an equal sign and then the value of the variable to the right. So if I said something like hello, var2 equals world, like this, and then I can do print var1, print var2, print var1 plus var2. And if you just have a guess about what this sort of thing would do, it'll probably do what you think it should do. So var1, anytime it sees var1 in the future, it's going to substitute the value of var1. We call the thing to the right of the equal sign the value of the variable. The thing to the left of the equal sign is the name of the variable. Anytime we see the name of this variable, so var1, we'll substitute the value at this location. So I'll run this, and you'll see that these steps right here, we printed hello for var1, we printed world for var2, and then hello world for var1 plus var2. One of the things that's, again, maybe will be a little bit confusing in Python is that Python is going to do exactly what you tell it to do, and it's not going to do like what you want it to do. So here, if we have two words, hello and world, we probably don't want to print out like hello world without a space in between. We want to have a space in between so that it's well formatted English. And in order to get those spaces, you have to be explicit and actually say, let's add a space like this. So here I'm adding these variables together, adding these string variables together with now a space in between them, and that'll give us a better English looking thing, hello space world down here like this. In HTML, we didn't, let's see, with some people we talked about how to do comments in HTML, but we didn't really go over that as part of the big class. But comments are going to be a big part of what we're doing in Python. Sometimes we want to have statements like up here, just English things like print is how we output to the screen, and the thing to the left of equals is the name of the variable, and to the right is the value. And these English statements, they have no meaning in Python. They're just to help the human who is reading the code or writing the code understand what's going on. And so they're called comments. And in Python comments begin with the hashtag. And you can have as many comments as you want, and they don't affect the running of the code at all. If I didn't have this hashtag right here, just put the English like this, then that's going to give us all sorts of errors that this is not valid Python code. And so let's put that back in and rerun this. Eddie.
So for var 1 and var 2, is that specific tag only for characters or just whatever name?
Good question. We'll get to it in a second. Was there a hand over here? How would you actually print out a hashtag? Good question. So here, anytime you do the print statement, what you're printing, like, must be contained in the quotation marks. Things in quotation marks, things in quotations are called string literals. So it's a literal because it is literally a string right here. This is a string literal. var1 and var2 are strings, but they're variable strings, not literal strings. So string literal, variable string. And the question was, how would we actually print out a hashtag? I'm going to generalize that question into think about how would I actually print out, say, like var1 like this. And anytime you want to print out something, like literally print this out, it must be in a string literal. So we could do hashtag like this, and that'll print that out. Or if I want to literally print out var1 like this, I put it in quotation marks, and it will literally print out var1 because this is a string literal. And this is not a comment because it is inside of a string literal, and it will print those out literally. So there's my hashtag, and there's my var1. Yes? Question is, why did I use double quotes here instead of single quotes? In Python, there's no difference between double quotes and single quotes. You can interchange them all freely. They are both string literals. Whether you use a double quote or a single quote, they are both string literals. Absolutely no difference at all. Yes? Sorry, I'm having trouble hearing.
So like line 10 11 where you just did like var1 and var2 without the quotes, so that's a string variable.
Yeah, so var1, var2 here, these are string variables. var1 here inside quotation marks is a string literal. And again, all of these vocabulary things, not going to be directly quizzed, but I'm going to be using these vocabulary words all throughout the semester, and so you just need a working knowledge of what they are. See, the next type of comment in Python, so again, hashtag is the comment, but the hashtag is only applicable to commenting out one line at a time. In Python, if we want to comment out multiple lines at a time, we use the triple quotes like this. So we have single quotes, double quotes, and then your keyboard doesn't have a triple quote character on it, but if you put 3 single quotes next to each other, we call that a triple quote. This is a triple quote, and you can comment out multiple lines at a time like this. So I'll save this. Now everything is commented out, so when I press the triangle button, nothing happens down here. But if I were to add, say, print test right here, Control S, save, triangle button, run, then it still runs things. So that if you want multiple line comments, triple quotes, single line comments, hashtag, and we'll be using those throughout lectures to add little notes to things, and they're widely used in practice and real programming. And again, these notes files that I'm writing, they'll be uploaded to GitHub after class, so you'll have access to this exact file right here. Okay, so far we've talked just about strings in Python. It's also, let's see, really the where computer science comes from is as a discipline, computer science comes from mathematics. And so the very first variables in programming languages, starting out back in the 1960s, were for numbers. And so numbers in Python are also handled similarly to strings. So if we'll have, let's do x equals 5, y equals 7, like this. And then we can do something like print x plus y to output the result of adding x and y together. If we do that, we get 12, because 5 plus 7 is 12. We can also do something like z equals x plus y, and then print out the value z down here, and we get the same result. So in HTML, we saw that there were lots of different ways to do things sometimes. In Python, it's going to be even more like that. There's never going to be like, here's the one right way to do something in Python. There's going to be literally hundreds of thousands of different combinations that are all perfectly correct. And as long as you're getting the right output in this class, then you're good. Yes? Yeah, this is a great question. So the question is about white space between variables. And the answer is that stylistically in Python, it's customary to put spaces. We call these equal sign and plus, we call them operators. It's customary to put spaces between operators, but it's not required. So I could do something like this, x plus y, no spaces, and everything still works. The main spot where white space is important is at the very beginning of lines. Like, so this would not be allowed because there's white space at the beginning of a line. And we'll see examples of why that's the case in a little bit. But in the middle of a line, you can basically have as much or as little white space as you want. Good question. So these 5 and 7 right here, these are called integers. Integers do not have a decimal place. We can, in Python, we can handle not just integers, but we can handle any particular, any kind of value. And so if I did say like 5.0 right here, x equals 5.0, that'll still work. And now it'll do 12.0 down here at the end. I can do something like 5.1, run this, and we get 12.1. These, if you're working with integers, integers are exact. Integers are exact, and all integers can be stored on your computer, no matter how large. So in Python, let's say we want to do exponentiation. So 5 raised to the power of 999. This double multiplication sign is exponential. And so this is 5 raised to this power. So this is going to be a really big number. Let's save this, run this. So this is the result down here. And it doesn't matter how big of a number you get to, Python is always going to store integers exactly. If, however, you are not working with integers, but working with those decimal numbers, things with a decimal inside of them, let's go ahead and come down here. If it has a decimal, in Python terminology, we call it a floating point number, or just float for short. And these floating point numbers cannot all be represented exactly. So the example that I like is 0.1 plus 0.1 plus 0.1. And then let's print x like this and run this. And so down here, this is the output of print x right here. And we can see that 0.1 plus 0.1 plus 0.1, that's obviously should be 0.3, but we can't actually represent the number 0.3 exactly in computer hardware for lots of technical reasons that you'd get into if you take upper division computer science classes. But this is the closest number that exists to 0.3. And so that's what it stores the number as.
Why doesn't Python get confused with two X's?
That's a great question. So the question is, I was doing a little bit of subterfuge here, that we have an X up here and we have an X down here. So remember that Python runs code one line at a time, starting from the top and going down to the bottom. And as soon as we have X equals like this, then at any point after this, we can use the X variable. If up on line 21, I tried saying print X like this, we'd say we have not defined X yet, because this equals is actually defining X, and you'll see there'll be an error message right here. I'll go ahead and run this, and we get this error message, name X is not defined. Now I'm going to delete this line 21 and resave this. So X is defined here, so I'm allowed to use X now. And then on line 27, we say this is a redefinition of X. Definition of the variable X. That it started off at one value, and now we've changed it to be a different value. And in Python, you're allowed to change variables after you create them. There are other programming languages where you're not allowed to change them, but in Python you are. And so that's what we've done right here, and now we're printing out the value right here.
So two questions. One, what if you put another X before print Z? Then will it recognize a different X?
So it's totally okay to have, as long as you have had an X equals at something before where you're using X, you can do whatever you want with X, and it'll be totally allowed, and no error messages.
And can Python function with like complex numbers?
Question is, can Python do complex numbers? And the answer is yes, but we're not going to talk about that yet. Let's see, so in this redefinition of the variable X, there's one more concept for us to talk about redefinitions, and that's that you can, so Python is what's called an untyped language. Python is an untyped language. What untyped means is that each variable is not assigned a particular type. And a type is something like the integers or the floats or the strings. And so once we have up here, we had X as an integer. Here we had X as a float. And now we can make X a string. X equals X is a string. And print X. And this is totally okay. A lot of AP computer science classes taught in high school use the Java programming language. This is very different than Java. Java is what we would call a strongly typed language. So you cannot change the type of a variable once it's created. Once a variable is a string, it's a string forever, can never go become an integer. But Python, you can change, you have a lot more flexibility. You can change the type of the variable to whatever you want it to be. Let's see. So let's go ahead and comment out now this block of code. And we're going to do get a little bit practical, sort of practical, depending on what your definition of practical is. But we're going to implement the quadratic formula. So quadratic formula. And so as a reminder, that is a squared plus or minus the square root of, thank you, b minus 4 times a times c divided by 2 times a, 2 times a. And here, anytime I have sort of a formula in that's commented out, this is sometimes called pseudocode. Pseudocode is like code, but it's not real code. Like code shows the recipe, but not, maybe has error messages, or maybe has some errors, just not complete somehow. And so the first thing that makes this not complete is, or that makes this actually wrong, is that I have my order of operations wrong here. And so order of operations is something that you have to be very, very careful, pay a lot of attention to while you're coding things. Here, this divided by 2a should apply to everything on the left over here, and we need to specify that with parentheses. So in Python, order of operations is the same as you would expect it to be from your normal math classes. The other thing is that like this plus minus, that doesn't really make sense. In Python, there's just a plus and there's just a minus. Plus minus isn't a thing. And we'll have to, so square root is a special thing that we'll talk about next. How do you actually do a square root of a number? If you want to do a square root, you have to do something called importing a library, import math. And so this is a keyword over here. Anything in purple is a keyword. Anything in purple is a keyword. And that means it's just something that's special built into Python. And then math, anything to the right of the import is called a library or a package. So math is a package/library. And then in order to get access to the square root function, it's math.square root like that. So let's go ahead and say like a equals 5, b equals 10, c equals 3, and then formula equals a squared plus the math dot square root of b minus 4 times a times c, all divided by 2 times a. And then we'll print formula like this. And run this. And we get this value error, math domain error. This is because anytime you get an error like this is related to, well, in this case, it's related to complex numbers that we have math.square root. If you take the square root of a negative number, that's when you get the complex numbers. In Python, complex numbers, by default, not allowed. You have to do special things in order to get complex and imaginary numbers. And so here, this b minus 4ac, I'm going to have to pick numbers that will make this whole thing right here be positive. So I'm just going to pick a really, really large value of b. Let's go ahead and say b equals 1,000. And rerun this. And now we get an actual value for the quadratic formula here. One thing just to note and pay attention to is that I've called this variable formula because I've assigned it equal to the quadratic formula, but it's not actually printing the formula down here. It's actually printing the number, the result. And so you can't actually say like print the formula. There's no way to print the formula in Python. You can only print the result of applying this formula to these variables. And let's see what happens if I do like something like a equals 10. So I change this value of a, and then I'm going to re-copy and paste this formula. Let's just do line 46 first. Down here like this, copy and paste that here, and run this. And you can see that I've changed the value of a right here. And so I might hope that this formula value is going to change as well, because I've changed a. So formula depends on a. So should we change formula? And the answer is that Python will only ever change a variable if it's to the left of an equal sign. If it's not to the left of an equal sign, then it will never change the value of the variable. So here on line 48, when I change the value of a, it does not change the value of all the formulas that depended on a. If I wanted to actually compute the new quadratic formula, I'd have to copy and paste this thing down here like this. And now if I print formula like so, now it'll actually print the updated value of the quadratic formula. This is especially for people who haven't done programming before at all, this is a common source of errors on the first lab. So this is just something to pay attention to right now, that Python, again, runs things one line at a time. And so as soon as it hits this line right here, it assigns the value to formula, but it's never going to assign a value to formula unless formula appears to the left of an equal sign. So, so this is a little bit nice so far that we're like, we don't have to calculate the quadratic formula by hand whenever we want to use it. But it's still, at this point, a little bit annoying that if I do want to use the quadratic formula, I actually have to know what is the quadratic formula and type out this entire expression in order to use it. Python has in every programming language, every procedural programming language has a built-in function called, a built-in concept called functions. So functions let us repeat or redo code without retyping the code. So here I'm going to say define quadratic formula. So def is another keyword. This keyword is for defining a new function. And then inside of parentheses, I pass in what values I want to use for the formula. So I'll say a, comma, b, comma, c, like this, just to be consistent with standard quadratic formula notation, colon, and then I'm going to copy and paste this line right here, Control C. Down here, I'll say result equals Control V, and then return results. So the common pattern, I'll show how to use this here in a second, but the common pattern for functions is that we have the def keyword at the very beginning, and then the return keyword at the very end. Inside of the function, this is called a block. Anything that's indented in Python is called a block. And what's indented here is the contents of this function. So this code right here sort of belongs to this function. Anytime we run this function or execute or evaluate this function, we will run, execute, evaluate this code down here. And these variables right here, we can specify what they are down in here so that we don't have to retype the entire formula every time. And so let's try print quadratic of 1, 2, 3 equals, comma, quadratic of 1, 2, 3, like this. Run this, save that, triangle button up here, run it. Whoops, I called it quadratic underscore formula, not just quadratic. So let's save that and run it. We got this math domain error again. So any of the errors that you can get inside of a function, you can get them outside and vice versa. And so to fix this, we're going to change this b here to 20, something big, save that, run it, and we got this value right here. Notice that this value is different than the previous values. So even though we have this result right here, we're getting something, something that's different. And that's because these a, these b, and these c values are different. We have 3, we call these parameters being passed into this function right here. This 1 corresponds to the A, this 20 corresponds to the B, and this 3 corresponds to the C. If I were to change these numbers to match what I had up here, so we had 5, 1003, come down here, put 5, 1003 like this, save that, run that. Now we'll get the exact same results. But I can also, if I want to call this function, evaluate it multiple times, and let's go ahead and delete these things right here. I can reevaluate this multiple times with different values without having to retype this entire formula, and it'll give me my different values for the quadratic formula. One last thing before I get to questions. Here, when I'm printing, there's something slightly new here. I've been putting a string in front of what I'm printing over here. This is something, typically when I'm printing things out, I will sort of tell myself what I'm printing out so that it's a little bit easier to follow along and read in the output down here. And so here we had quadratic formula 5, 1003, and save that, triangle button, run that, and this, what gets printed right here, is just this string value right here. Again, though, in Python, it doesn't do what you want it to do. It does exactly what you told it to do. So if I have, say, something here that's different than what's over here, it's not going to, this is an easy way to get confused, because even though on the left over here, it's saying quadratic formula of 5, 103 equals this, it's really quadratic formula of 5, 1003 that equals this. And so it's easy to get confused when things don't match up. Okay, I covered a lot of things really quickly there, so we'll pause now and go over questions. Natalie.
The comma that's basically like the string and the formula, that's like just that differentiates the two.
Yeah, so the question is this comma right here, what exactly is this comma doing? And the answer is that in this print statement, if you want to print out multiple things, you can separate them by commas. So we can do something like print A comma B comma C like this to print out 3 different variables. If you want to print out multiple things, you separate them by a comma inside of the print statement right here.
Is that interchangeable to like the addition sign?
Good question. The question is, how does this relate exactly to the addition sign that we saw before? I'll answer that properly next class, but I don't want to do an incomplete explanation of that this class. Good questions. Yes.
So what exactly like does the comment mean, and also why when you like you have to put formula back in again after changing to A equals 10, why would you do it?
The question is, what exactly does this comment mean? Is this the spot that you're looking?
It's like comment in general, and when you change like from A equals 5 to A equals 10 with line 48, did you just put in the quadratic formula again for it? Why would you do it in a comment? It's not recognized comment.
Okay, good question. So I'm going to real quickly comment out everything down here so that we can come up here and focus on just these 2 print statements and run that real quick. And here are the 2 outputs. And the question is, first of all, what exactly is the purpose of a comment? And the comment, again, is like, just tells Python, ignore everything after the hashtag on this line. So usually comments are used for like English explanations of what the code is doing, something to help the reader understand what the goal of the Python code is for. Sometimes comments are for, we have some code here and we just don't want to run this code, but we also don't want to delete this code. So here I've commented out this line, added this hashtag right here to say that here's a piece of code that I don't want to be ran, but I also might want it to be run in the future, so I'm not going to delete it just yet. And so what's happening here is we have this A equals 10, and we have this formula right here, but because this isn't a comment, it's not getting run. So when we print formula right here and print formula right here, it's the same formula value that's being printed. Even though we've changed the value of A, because we haven't changed the value of formula, we're printing out the same thing right here and right here. Let's go ahead and triangle button, run that. Same exact values for formula on this line and this line. If I uncomment this line, so delete the hashtag, now this code is going to be evaluated. It's going to be run by Python. So on line 49 right here, it's going to actually change the value of formula. And so on line 50, it's going to print out the different value with the updated A equals 10. So the purpose of this comment right here was just to illustrate that this, this line is not being run, and so that's causing this not to be updated. So if ever you see code that's inside of a comment, then you just can ignore that code. It's not something that Python's going to do. Yes?
Can you slow down a little bit?
Yep.
So when you put like, when you're like doing the string literal quadratic formula, then you use comma after the literal comma to separate the actual quadratic formula and the string literal.
Exactly. So it's first going to print the thing to the left of the comma, then going to print the thing to the right of the comma. So if we triangle button run this, here it first printed the thing to the left, then printed the thing to the right. If we wanted to something like print 4, 5, 6, 7, 8 like this, save that, print, it'll just print all of these things one after the other. So it's just I guess the comma's just a shorthand way of printing out multiple things at the same time. Yes?
When you define like a variable, what's the purpose of returning the function before print?
So your question is, what is this return on line 56 about?
Can you just go ahead and print it, or do you have to return it?
Yeah, this is a great question. The question is, why am I returning here? What exactly does this return statement do? And in order to explore that a little bit, let's comment all of this out and let's try running. I'm also going to comment out the stuff that we had above so that it's only going to be the function definition that we have. So all that we have right now is this function definition like this, Control S, save, triangle button, run. We have no output down here because we have no print statements. Now let's see what happens if we run quadratic formula of 5, 1000, 3, like this. Save that, run this, and whoops. I also commented out the import math, so let's go ahead and add that back in. This error message here saying name math is not defined. That's referring to this math right here. And because I commented out import math, that's why it was not defined. So save that again, triangle button. And now we still have no output on the screen down here. And so one of the, I guess, general principles is that if you don't have a print statement, then you won't output to the screen. This return, we'll see some situations in the future where this return can cause output to the screen. But for now, if you don't have a print statement, you can't output to the screen. If we wanted to actually view this result, we'd have to say print like this. And we get that result. What this return does is it says anytime you have the name of your function, in this case quadratic formula, with these values passed in, basically delete this from this line of code and substitute whatever this variable right here is. This variable happens to be equal to this big formula, so it computes the quadratic formula and then substitutes it right here and then prints it out. But we don't have to just print it out directly. We could do something like x equals that and then print x like this. And now the x right here gets assigned to be the result or the return value of the quadratic formula up here. Again, we call this function, assign a, b, c to these three values, evaluate this right here, put it in this variable result, and then pass this variable result down here, substituting this out for the result value, stick it in x, and then print out x down here. If all we wanted to do was to print out the value, then we could say comment out these lines and have a print function, a print call inside of here, like print result. And this would be exactly the same, oops, assuming I still call it. There we go. Like this. This would give me the exact same end result of printing it right here, but it's much less useful in practice, because now what if I wanted to print out, say, the result of quadratic formula plus 1? If I tried to do print x plus 1, so hopefully what we're wanting is to get like 29.065. Run that, we'll get an error message. But if we change this to return results, then instead of printing it immediately, it's going to do the variable substitution right here, set x equal to that 28.065, and then we can use this number just like any other number and add 1 to it to print it, or do whatever other computations we want to do on it. So now we get the 29.065. So in general, it's inside of functions, you probably want to be using return, and only outside of functions using print. Not 100% of the time, but that's the typical use case. Lots of good questions so far. Any other questions at this point? Yes.
Are all library packages already installed? And I realize you mentioned
This is a great question. The question is, what library packages are already installed and not installed? So when you just download Python and install it, it's going to come with math, and it's going to come with hundreds of other pre-built-in things. In a couple of weeks, we'll see how to download other packages, and it turns out to be really easy to do, and that's one of the things that's really powerful about Python. That in about 2 or 3 weeks, we'll be downloading videos from YouTube and using Python to strip ads out of those videos automatically for us. And we'll be doing that using other people's library code that does all the hard stuff, and we just chain it together inside of our code. So good question. Any other questions so far? Okay, I'm going to switch over to our cheat sheet so we can just see what kind of things we've covered today. So under this base types, we've talked about ints versus floats versus strings. Let's go ahead and talk about this bool type next. So a bool or a boolean is something that can be either true or false. So back over here, if we were to say something like x equals 5 and then print x greater than 10. Well, x is not, 5 is not greater than 10, so this would be false. False. If we were to do x less than 10, now that is true, and so that will evaluate equal to true. Back over to the cheat sheet. These Boolean operations are something that we're going to talk a lot about in class on Wednesday. And if we come down here, I think it's on the second side. Let me look at my printed one so I can see it. It's on the first side, on the bottom left, this Boolean logic. This would be, if you haven't seen this before, this is something to make sure that you know really well on Wednesday, because we're going to be talking about this a lot on Wednesday. And there's, again, a video from the textbook that goes over all of these. And so if you haven't seen these before, make sure to watch that video. And we'll talk about that on Wednesday. So we've talked about, let's see, the last thing in this top left box is this bytes. This is something that's fairly involved, so we're not going to talk about this for a long time. But otherwise, the int, float, bool, string, we've talked about everything that you need to know. Well, let's see, we have another minute in class, so we'll talk about the string just a little bit more. And what if, so we've mentioned that, so the string literals, this is a string literal. This is how you put in string literals in Python. But what if I needed to say, let's see, instead of this is, let's change it to that is, but let's make it a contraction saying that's. So I want this apostrophe like this. And so if I want to include an apostrophe, now Python thinks that this right here is the actual string, and it doesn't know what to do with the rest of this. One thing that we can do is put double quotes around this whole thing, and now Python knows what's going on. But let's say I wanted to also put double quotes around string literal like this. We can use a backslash in front of a character like this. A backslash says that ignore what's written here, and it's not the actual thing that terminates the string. It's going to be printed as actually a literal double quotation mark inside of the string. So save that, run that, And now that's how you include the apostrophes and the double quotation marks inside of a string, is you put the backslash in front of them. And this is what on the cheat sheet they're referring to right here. This is an escaped string. This backslash apostrophe is called escaping the apostrophe. The backslash is called the escape character. So that's how you include special characters inside of strings. That's everything for today. I'm happy to answer more questions after class, and I'll have my office hours right now as well to answer questions either about this or about the homework. But I will see you all on Wednesday.
So, Professor,
Yes.
in the homework, so we have to have